Hey class, in today's lesson we are going to discuss polynomial functions, which is found in section 5-1 part 1 of your book. Our objective is to classify polynomials. So here's just a little bit of vocabulary. It says a monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. And just kind of give you an idea of what that means. A real number might be like, for example, 5. A variable might be, for example, a. And then a product of a real number and one or more variables might be, for example, 5ab. Okay. It then goes on to say the degree of a monomial is in one variable is the exponent of the variable. A polynomial is a monomial or a sum of monomials. So poly means more than one. So what I wrote above, the 5, the a, and the 5ab are all monomials. So if I added them all together, that would be considered a polynomial. And then it goes on to further say that the degree of a polynomial in one variable is the greatest degree among its monomial terms. All right, and then it goes on to say that standard form, and we've kind of heard the term standard form before. It's just like, your basic form. So our basic form of a polynomial function would be where you arrange the degrees from highest order to lowest order. And so you'll see in the example below, the highest order is 3, so it's the cubic one. Then it goes down to second power, which is quadratic, the first power, which is linear, and then the no power or the 0 power, which is considered a constant. And so here's the chart or the table with the names, how you name a polynomial based on its degree and number of terms. So based on the degree, you'll say constant if there are, no variables. Linear if it's the first power, quadratic is second power, third power is cubic, fourth power is quartic, and fifth power is quintic. And we normally we for this class, for the most part, won't really go higher than cubic as far as dealing with actually manipulating, but we will see quartic, quintic, and higher. Okay. And then for the number of terms, we really only have names for the first 3 terms of a polynomial, and that's monomial, binomial, trinomial. And then after that, you name it based on the numbers. So if it's 4, you say a polynomial of 4 terms, or if it's 5, you say polynomial of 5 terms. So in our first example, we are asked to write it in standard form and then to classify it based on the degree and number of terms. So we need to put it in order from highest order to lowest order. So the highest order would be 9x squared plus 3x plus 5. Okay, then we would name it. So we name it by degree. So the highest degree is to the second power, so that's called quadratic, and we know that because we just left out of that section. So this is a quadratic and it's 3 terms, so it's a trinomial. Quadratic trinomial. And the next one, we need to put them in order. So again, x to the 4th will be first. Then we have negative 6x squared plus 10x squared plus 4x and minus 12. That's a 1. What we should notice is that we have more than one x squared. So we need to combine like terms to take x to the 4th plus 4x squared plus 4x minus 12. Okay, and so then from here, we would call this a quartic sorry, I just kind of got lost. A quartic polynomial of 4 terms. Okay, so let's look at the try. All right, in our try again, we'll do the same thing. So highest order to lowest order. So that'd be 5x to the 4th plus 3x to the 3rd minus x. So that'll give us 4th power is highest. So this would be a quartic. And we should be able to remember quart for fourths, right? Or a quart of a gallon. So this is a quartic trinomial. And then the second one, if we put that in order, that'd be negative 4x to the 5th plus 2x squared plus 3 plus 10. If we combine those like terms, that'll give us negative 4x to the 5th plus 2x squared plus 13. And this one is going to be called a quintic trinomial. All right, let's keep going. All right, so a little bit more vocabulary. It goes on to say that the degree of a polynomial function affects the shape of its graph. So it determines the maximum number of turning points or places where the graph changes direction is what a turning point is. It also affects the end behavior or the direction of the graph to the far left and to the far right. So we're not going to talk about turning points just yet, I don't believe, but we are going to talk about the end behavior. And so when I think about the end behavior, I'm talking about the tails of your graph. Where are they going to be pointed? Are they both going to be pointed up? Are they both going to be pointed down? Is one up, one down? Which one is which, right? So let's figure out what determines what. So here's an example, and you may want to copy that down. So it's going to be up and up for the example below, down and down for this example, down and up for this one, and up and down for this one. And what would be really good practice is if you could kind of look through the polynomial and determine, well, what's the difference between up, up, and down, down, right? And then, for example, what's the difference between the last two, down, up, and up, down? How can you tell which one is going to be which, okay? And then maybe go back and figure out, well, what's the difference between up, up, and up, down? And what's the difference between down, down, and down, up? And if you can kind of think about those thoughts, then it'll help us when it comes to kind of remembering what and why. So here we go. So we have a table. It's talking about the end behavior. So when A, which is the coefficient of your leading term, when A is positive and N is even, so the number of so N would be your exponent. So when A, your leading term, is positive and your highest power is positive, then it's going to be up, up. When your leading coefficient is positive and your highest exponent is odd, then it's going to be down, up. When it's negative, when A is negative and your N is even, so your exponent is even, then it's down, down. And when your leading coefficient is negative and your highest exponent is odd, then it's up, down. And one way in the past that we kind of remembered what was what, up, up, and down, down aren't very difficult to try to memorize. Positive and even, negative and even. So basically when it's an even exponent, know that they're going to be the same. They're going to be either same up or same down. But when it's odd, you think about it as far as like the slope, for example, of a linear line. So what do I mean by that? So for example, if I had a line such as this, right? This is originally going from down to up, right? But notice that the slope, so the slope would be positive. And when you think about slope, slope is your leading coefficient. Which is the same thing as A. So that makes sense. So in other words, when it's down, up, it makes sense that your slope is positive. So it's because your A is positive. And so the same thing when it's, for example, a negative slope, you went from up to down, right? And it's because your slope or your A was negative. All right. So let's practice. So first we need to be sure that it's in standard form. If it's not, then we need to put it in standard form. And then from there, we determine what it's going to be. So what I like to check for first is the power even or odd? Because if it's even, then I know they're going to go in the same direction. If it's odd, I know they're going to be opposite directions. So here's the deal. The first one is odd. So that lets me know they're going odd and opposite, right? So they're going to go opposite directions. And then our leading coefficient is positive. So it should, right? It should look like a positive slope, which means it's going to go down and up. And that's your end behavior. Let's look at the next one. This one is even, right? It's even, so I know they're going to start the same and end the same, right? And so what I notice is that this is odd. So this is going to be down and down. because it's negative. All right, let's try the next one. We have negative 4x cubed plus 2x squared plus 7. So again, I look, my highest power is cubed. Well, first of all, it's in standard form, and then I notice that my highest power is cubed. So since it is cubed, I know they're going to be, it's odd, so it's opposite, right? So if they're opposites, then I need to look at the coefficient. It's negative. So in other words, it should look like a negative slope, which how does it end? It goes up and down. And we are done, guys. Remember, if you have any questions, please come see me for tutoring.